Good morning. Today we're going to talk about linear regression and modeling. So we're moving into a little bit of statistics that is attached to linear functions. If you were in algebra with Mrs. Esposito, you've done the Inspire part before. I would suggest that you still watch the one example that I do with you to make sure you remember. We do a lot of modeling this year and it's not all linear. And so once you've got the calculator sequence really good, you've mastered that with linear regression, then the rest will seem really easy. So take some time today to refresh your memory. If you haven't done regression on the Inspire before, it's not a big deal. I'm going to carefully go through that with you at the end of this lesson. So here we go. We have some definitions to get through first. The first is bivariate data. And bivariate data is really exactly what it looks like. Bi means two, variate means variable. So bivariate data is data involving two variables. So what we're doing is we're looking for an association between variables. And you'll see examples of that as we go along. A few more definitions. An independent variable is a variable whose value does not depend on another's. Typically, this is our x value or our domain. We always put the independent variable on the x-axis. Likewise, the dependent variable has a value that does depend on another. And we talk about this now because we have to decide how to set up our scatter plots often. Which variable depends on the other. Does weight depend on height? Does height depend on weight? Do test scores depend on time studying? Things like that. So you need to determine what depends on the other, which is independent and which is dependent, so that we set up our scatter plot correctly and do our regression correctly. So speaking of scatter plots, a scatter plot is a statistical plot. And you can see they're down here. They're scattered points, scatter plot, that shows a relationship, or lack of, between two variables. So we use this with our bivariate data. Here are some examples of how we would describe associations using scatter plots. So notice we have words like strong and weak or none. Another word I would add is moderate. Sometimes there's, something kind of in between strong and weak. We call it moderate. You'll learn in statistics we do a lot of generalizations. And then you also see words like negative and positive. Those are easier to see. Negative refers to the slope of the line. So you can see that these scatter plots, if we fit a line to them, the slope would be negative. And similarly, positive refers to the slope. If we were able to fit a line to these scatter plots, the slope of that line would be positive. So the negative and positive refers to slope, direction. Moderate, strong, weak refers to how close to a line the points are. So this is considered a strong negative correlation. The points all cluster very close to a line in the negative slope direction. This is a weak negative correlation. Many points are farther from a line. It's like a fatter line, I guess. No correlation, you really can't get a line there. A weak positive correlation. And they call this a strong positive. I might call this more moderate. But again, you can probably argue either way. That's not the important part at this point. You deal with that more in the AP statistics. Okay, so the last bit of vocabulary for the day, and then we'll move into our Inspire use, is a linear correlation coefficient. Linear correlation coefficient has an abbreviation of R. So we're going to find that in our Inspire at some point. But the definition of a linear correlation coefficient is the strength of the linear relationship between two variables. So it's some number that attempts to measure the strength of the linear relationship. Now, r is always a value between -1 and +1. You can never have a number bigger than +1 or less than -1 for an r value for strength of a linear relationship. And the closer the absolute value of r is to 1, the stronger the relationship. So if we come back up here to these scatter plots so that you understand, what will happen is we'll get data, we'll create scatter plots, we'll find the line that fits the points best, and then we will calculate a value for r. Our calculator will do that for us. And r is associated with the scatter plot. It's the strength of the linear relationship. So here I have a strong negative correlation. I'm going to have a negative r value, and it's going to be pretty close to 1, maybe -0.8, -0.9, who knows. This is a weaker negative correlation, so it's still going to have a negative r value, but it's going to be less close to 1, so maybe -0.6, I don't know. No correlation, this is going to be close to 0. A weak positive correlation, so this is going to be positive, sloped positive value of r, and maybe, again, like a 0.7. Moderate or strong positive correlation might be a positive 0.8. So that's the relationship to the scatter plot and the value of r. R has the same sign as your slope, and the closer its value, its absolute value is to negative or to +1, the stronger the relationship. Okay, enough talking. Let's do some Inspire work.